Continents pretend to be steady, but they're actually slow travelers drifting across a restless planet. We move around our business as if the ground stays loyal forever, but it's always creeping along a warm, mobile layer deep below. The whole planet is basically a giant conveyor belt running so slowly that we never notice. If you pause to imagine everything shifting beneath your feet, the world will feel a lot more alive. I'm Mike with List 25, and these are 25 surprising facts about the Earth's continents and plates. 25. Continents float on a soft layer. The continents rest on a warm, partly molten layer called the asthenosphere, which behaves like incredibly slow-moving taffy. This layer isn't liquid enough to flow quickly, but it is soft enough to let entire continents glide over millions of years. Think of them like gigantic rafts drifting on a deep heated cushion. We don't feel the motion because the shifts are tiny each year, but they add up to dramatic changes over time. The crust floats on this flexible layer, which makes mountains rise, valleys stretch, and oceans broaden. If there weren't this soft base, the continents would stay in place and the Earth would look very different. Every major geological process we know, from the building of mountain belts to the opening of ocean basins, depends on the way the crust slides slowly but steadily over the asthenosphere. It's the quiet engine behind our planet's ever-changing surface. 24. Parts of Europe are still rising after the Ice Age. Northern Europe is actually still bouncing back from the last ice age. Back then, massive ice sheets crushed the crust like a giant weight. When that ice melted 10,000 years ago, the pressure vanished and land started to slowly spring back up. This process is called isostatic rebound, and it's still happening right now in places like Sweden and Finland. In some spots, the ground rises a few millimeters every year. This silent uplift reshapes the coast, pushes old shorelines above sea level, and even messes with how harbors work over time. Even ancient fishing villages that used to sit on the water are now stranded way inland. 23. Australia is drifting north fast. Australia travels north at about 7 centimeters each year, making it one of the fastest moving continents on Earth. However, this movement caused an odd problem. The entire country's GPS coordinates slowly drifted out of sync with reality. After enough time, the difference became so large that digital maps no longer matched the actual landscape. The government eventually had to correct Australia's official coordinates to keep navigation and technology accurate. The continent's northward push is driven by the Indo-Australian plate pressing towards Southeast Asia. Over millions of years, this movement will reshape coastlines, push up new mountains, and shift the region's geography. For now, it simply means that everyday life continues on a continent quietly cruising forward. 22. The Himalayas are still growing. The Himalayas were born when the Indian plate began crashing into the Eurasian plate, and that collision is still happening today. As the plates push against one another, the crust wrinkles and folds upward exactly like an imperfect shuffle, raising the mountain range a few millimeters each year. Erosion constantly wears the peaks down, but uplift keeps them tall. This slow but unstoppable push is also why the region experiences frequent earthquakes. Mountains aren't frozen relics from the past. They're active and evolving, shaped by collisions deep below the surface. If you could watch millions of years unfold in seconds, the Himalayas would appear to rise and shift like waves in slow motion. Every peak, ridge, and valley in the region is part of this long, ongoing story. 21. Antarctica used to be green. Antarctica is now a frozen world of ice and wind, but long ago, it was warm, lush, and full of life. Fossils show that forests once covered the continent, with rivers winding through landscapes filled with plants like ferns and conifers, and even dinosaurs roamed there. The transformation happened because Antarctica drifted to its current position over the South Pole. As it drifted, the climate flipped, temperatures plummeted, and massive ice sheets grew. The continent's trip across the planet totally changed its identity. It's weird to imagine Antarctica as anything but icy, but the proof is right there. The ground beneath the ice once supported thriving ecosystems. 20. There were once only 2 supercontinents. Earth's continents have crashed together and split apart repeatedly, building massive supercontinents that lasted millions of years. Rodinia and Nuna, also called Columbia, existed before Pangaea. As landmasses drifted and slammed into each other, each supercontinent grew. Eventually, the very same forces that built them tore them apart again. This cycle occurs slowly yet consistently, propelled by the movement of tectonic plates. Today's continents are only the newest arrangement in an ever-changing pattern. 19. Pangaea will happen again. The continents we recognize today are drifting, and scientists expect them to eventually collide and merge into a future supercontinent. Another scenario, Pangaea Ultima, suggests the continents could reunite in a configuration similar to ancient Pangaea. Whichever version unfolds, the process will take 200 to 300 million years. The early steps are happening now as the Atlantic widens and the Pacific gradually shrinks. The supercontinent cycle never stops, and our current map is only temporary. 18. South America and Africa fit like puzzle pieces. Looking at a map, the curve of South America's eastern coastline fits almost perfectly against the shape of Africa's west coast. This is not a coincidence. The continents were once connected as part of Gondwana, a massive landmass that also included India, Antarctica, and Australia. When the Atlantic Ocean began opening, South America and Africa drifted apart, leaving behind coastlines that still reflect their old connection. Rocks and fossils provide even more proof. The same species and layers of stone can be found on both sides of the ocean, showing that they have the same geological history. Even though the continents are now separated by an ocean, their shapes and structures still reflect the tale of how they got there. 17. Earth has 7 continents, but 15 major plates. People often learn about the 7 continents, but the Earth actually has around 15 major tectonic plates, plus many smaller ones. Continents ride on the top of some plates, but other plates are mostly oceanic. These plates move independently, shifting at different speeds and in different directions. They collide, slide past one another, or pull apart, creating the planet's most dramatic features. Earthquakes, volcanoes, mountain ranges, and ocean trenches all form along plate boundaries. Understanding plates helps explain why the planet looks and behaves the way it does. Continents are just passengers in a complex system of moving slabs. Once you see the world in terms of plates instead of continents, the patterns of geological activity make a lot more sense. 16. Continents have deep roots that sink into the mantle. Continents aren't just thin skins sitting on the surface. They have deep, thick roots that extend far down into the mantle, much like the underwater part of an iceberg. These roots are made of lighter, buoyant rock that helps continents float higher than the denser oceanic crust. This is why continents stand tall above sea level, while ocean basins sit much lower. These deep roots also make continents stubborn. Because they're thick and buoyant, continental crust is hard to destroy. Instead of sinking easily into the mantle, it crumples, folds, and builds mountains when plates collide. What we walk on is only the tip of the structure. 15. The Atlantic Ocean is growing. The Atlantic Ocean is basically Earth's long game of slow stretching. At the mid-Atlantic ridge, magma rises and pushes the seafloor apart 1 centimeter at a time. It's wild to think that the ocean you see on a map today isn't the same ocean people saw millions of years ago. The Americas are inching west, while Europe and Africa ease east, and even though you would never notice it standing on the beach, the effect is constant. You could be sipping a drink on the coast of Brazil and be drifting farther from Angola without feeling a thing. 14. A hidden continent lies beneath New Zealand. Most people think continents are easy to find on a map, but one of them is almost totally underwater. Zealandia is a huge piece of continental crust that snapped away from Gondwana millions of years ago and slowly sank beneath the waves. About 94% of it sits below sea level, with only New Zealand and some nearby islands poking above the surface. Geologists call Zealandia a continent because it has a thick continental crust, clear boundaries, and its own geological history. 13. The Dead Sea Rift created the lowest land point. The Dead Sea sits in a massive sinkhole carved out by the Dead Sea Rift, part of the bigger Jordan Rift Valley system. This isn't just a low spot on a map. It is the lowest dry land on the entire planet. The rift is a border where the Arabian Plate rips away from the African Plate, stretching the crust and building a deep basin over millions of years. As the land sank, water filled in, creating the salty lake we know today. 12. California moves a little every year. While California may look firmly attached to the US, it's actually slowly sliding northwest along the San Andreas Fault. The Pacific Plate slides past the North American Plate at about 5 centimeters per year, which sounds tiny, until you think about what happens when that movement sticks, slips, or snaps. It is pure power. The tension fuels many of California's earthquakes. The landscape around the fault zone carries the scars of this constant grinding. Hills, valleys, offset streams, and broken rock layers reveal where the plates have danced past each other. The cool part is that California is literally inching closer to Alaska. Extremely slowly, but undeniably. When people joke that LA will someday be a suburb of San Francisco, they're not entirely wrong. 11. Japan exists because plates collide. Japan owes its existence to tectonic collisions. The Pacific Plate dives beneath the Eurasian Plate in a powerful subduction zone that pushes up volcanoes, mountains, and new crust. This ongoing process is why Japan has such dramatic topography, including steep mountains and active volcanic arcs. The islands are basically built from the debris and lava created where the plates meet. That same collision also fuels earthquakes, making Japan one of the most seismically active places on Earth. Yet the same forces that bring risk also bring beauty. The rugged coastline, iconic volcanoes like Mount Fuji, and deep ocean trenches all trace back to this plate boundary. I mean, where else is Godzilla going to live? He needs room. 10. Mount Everest moves. Mount Everest, the tallest mountain on Earth, isn't done growing. The collision between the Indian Plate and the Eurasian Plate keeps pushing the Himalayas upward by a few millimeters each year. It's slow, but steady. Even the peak itself shifts slightly over time. Every rock layer in the region tells the story of violent uplift, pressure, and folding. Fossils of ancient sea creatures have been found high in the Himalayas, which blows people's minds until they realize these mountains were once part of an ancient seafloor. Everest is a monument to tectonic force. When climbers reach the summit, they stand on a crust that was dragged upward by one of the most powerful plate collisions on the planet. 9. Earthquakes mostly happen on plate boundaries. Over 90% of the world's earthquakes hit along plate boundaries. These are the places where plates collide, slide, or pull apart, building tension until something finally gives. When rocks snap or slip, the energy is released as seismic waves. That's the shaking we feel. The Ring of Fire, a horseshoe-shaped zone around the Pacific, is packed with these boundaries, which is why it hosts so many earthquakes and volcanoes. Transform boundaries like the San Andreas Fault produce their own kind of action as plates grind sideways past each other. While divergent boundaries like the Mid-Atlantic Ridge are quieter, the plates still shake as they move apart. 8. The Red Sea is a growing ocean. The Red Sea is basically a baby ocean in the making. It sits along a spreading boundary where the Arabian Plate is pulling away from the African Plate. As the plates separate, magma rises and creates a new crust, slowly widening the basin. Millions of years from now, the Red Sea could look a lot like the Atlantic. Right now, it's narrow, warm, and packed with beautiful coral reefs, but beneath the water is a clear sign of what is coming. The crust is thinning, volcanic activity bubbles beneath the surface, and the sea floor spreads bit by bit. 7. New crust is born every day. Earth is constantly creating new crust at mid-ocean ridges. The process is simple but powerful. Magma rises from the mantle, cools, and locks into place as solid rock. Then, more magma rises, pushing the older rock aside. This conveyor belt of creation runs non-stop, adding several square miles of new crust every year. You would never notice it standing above, but the ocean floor is one of the most dynamic environments on the planet. Fresh lava forms intricate patterns as it cools, shaping ridges and valleys along the spreading centers. It's easy to forget that the crust under the oceans is far younger than the crust on land because it's always being remade. 6. But old crust gets recycled. Think of the Earth as a giant recycling machine that never stops. While fresh crust is constantly being born at mid-ocean ridges, the old, tired floor has to go somewhere. That's where the subduction zones come in. Massive oceanic plates literally dive under continents, swallowed by the hot mantle below. Once they're down there, the rock melts away, turning into the raw fuel that eventually powers massive volcanic eruptions. It's a mind-blowing reality. The very ground beneath the sea isn't permanent. It's created, dragged across the planet, and then wiped out. If the Earth didn't recycle itself this way, it would literally run out of space, or expand like a giant balloon. This constant balancing act is what builds our mountain ranges and fuels the world's most famous volcanic chains. 5. Madagascar was once attached to India. Madagascar feels like its own world because it was once part of a different world entirely. Millions of years ago, Madagascar and India were connected within the supercontinent of Gondwana. When the landmasses began to split, India raced north toward Asia, while Madagascar stayed behind. This separation allowed Madagascar's plants and animals to evolve in isolation, leading to the incredible biodiversity the island is known for today. Geologically, the island still carries the clues of its ancient connection through matching rock types and structures found in India. The story of how these two landmasses drifted apart is a reminder of how plate tectonics quietly shapes not just landscapes, but entire ecosystems. 4. The Great African Rift has active volcanoes. The Great African Rift is one of Earth's most dramatic features, stretching thousands of kilometers across eastern Africa. It's a place where the African continent is literally tearing itself apart. The crust thins, valleys sink, and magma rises, fueling a string of active volcanoes. Places like Nyiragongo and Erta-Ale are famous for their lava lakes that glow like portals into the deep earth. This constant movement changes the scenery around the fissure. The story of extending crust is told by tall cliffs, wide valleys, and lengthy lakes. If this continues for millions of years, this section will totally break off, resulting in a new ocean. 3. Some plates are tiny, but important. Some tectonic plates are small, but that doesn't stop them from throwing their weight around. The Juan de Fuca plate is a great example. It's tiny compared to giants like the Pacific plate, yet it plays a huge role in shaping the Pacific Northwest. This little plate is busy sliding beneath North America, feeding magma into the Cascades and setting the stage for big earthquakes. You can thank it for volcanoes like Mount St. Helens and the kind of seismic energy that makes geologists sit up straight. Small plates often hide in places people don't notice, but they control important geological processes. Their movements influence coastlines, mountains, and entire ecosystems. A plate's size does not determine its impact. Even a small slab of Earth's crust can carry enough force to shape landscapes and influence millions of lives. 2. The Caribbean plate is squeezed from all sides. The Caribbean plate is a small but tough piece of Earth's crust caught between giants. North America presses from one side, South America from another, and the Cocos plate shoves in from the west. All that pressure turns the region into a geological crossroads packed with earthquakes, volcanoes, and shifting coastlines. The Lesser Antilles Island arc exists because this plate is forced upward as the Atlantic seafloor sinks beneath it. The deep offshore pits and towering summits of such long chains of islands are clear signs of repeated collision. The Caribbean plate also shapes the seafloor around it by tugging and pushing the land into different shapes over millions of years. 1. Earth's continents are still moving. Every continent on Earth is drifting, even if the movement is far too slow to notice. North America slides west, Africa stretches apart, Australia marches north, and Antarctica glides around the bottom of the world. These motions are tiny each year, but they never stop. Over millions of years, the continents trade neighbors, reshape oceans, and build mountains. The ground beneath cities, forests, and coastlines is on a constant journey, whether we realize it or not. This slow migration explains why ancient fossils show up on the wrong side of oceans and why coastlines that seem unrelated mirror each other's shapes. The continents we know today are temporary arrangements in a long planetary story. Give Earth enough time, and the map will look nothing like the one hanging in classrooms. The continents feel fixed in a position because they move very slowly, but as we've seen, nothing about Earth's surface is fixed. Mountains rise, oceans spread, and entire continents drift without asking permission. The map we learn in school is just a snapshot in a much longer story. Thank you guys so much for watching. As always, if any of these facts surprise you, or if there's a geological mystery we missed, let me know in the comments. Don't forget to like, share, subscribe, notification bell, do all that fun stuff, and I'll see you in the next one.